Welcome back everybody. For this video I'll be discussing the reduction of carbonyls to form alcohols, and I'll be dealing with hydrogens and hydrogen sources. And if you recall back to my Grignard reaction video, the Grignard reaction was an example of reducing carbonyl compounds to form alcohols, and the way it did it was that the R served as a nucleophile, and it added into the carbonyl system. It added into the carbon of the carbonyl, and it reduced it to form the alcohol. And you had this little intermediate step, this H2O H plus workup, to neutralize the negative on the oxygen. Now, in the same token, the focus of this video is similar to the Grignard reaction. However, instead of R groups acting as the nucleophile, we'll be dealing with sources in which the hydrogen will serve as a nucleophile. And those sources are sodium borohydride, which is NaBH4, and lithium aluminum hydride, which is LiAlH4. And the four carbonyl compounds that I'll be focusing on are the ketone, aldehyde, carboxylic acid, and ester. So let's get started. For the ketone, we use sodium borohydride. You can use sodium borohydride or lithium aluminum hydride, and it will reduce this carbonyl to give you a secondary alcohol. The mechanism is similar, almost exactly the same as the Grignard reaction, but instead of adding a R group, you'll be adding a hydrogen into the system to reduce it, and you'll still have the intermediate step of this H2O H plus workup to neutralize the negative on the oxygen. So I'm not going to draw the mechanism for these reactions. You could just go to my Grignard reaction video and just look at that, and I'll show the mechanism in I show it fully. And again, the ketone can be reduced by the sodium borohydride or the lithium aluminum hydride to give you your secondary alcohol. So you just add one hydrogen into the system and neutralize the negative O to give you your secondary alcohol. And again, how you can determine if this is a secondary or primary or tertiary alcohol, you look at the carbon directly attached to the oxygen. Since the carbon is attached to two other carbon groups, we say that this carbon is secondary, so we say that the oxygen is also secondary since it's attached to a secondary carbon. Okay? And that's the way you determine if your alcohol is primary, secondary, or tertiary. Next is the aldehyde. Again, the aldehyde can be reduced by sodium borohydride or lithium aluminum hydride. It's either or. And use H2O H plus workup. And again, you'll add one hydrogen into the system, and then it will give you your primary alcohol. Again, this carbon is attached to one other carbon, so since this carbon is primary, that means the alcohol is also primary. So again, you form a primary alcohol. Okay, now the third reaction is carboxylic acid. Okay, the carboxylic acid, instead of adding one hydrogen into the system, you add two hydrogens into the system. Okay, mechanism is still the same. It doesn't change. You might just have an extra step, but you're adding two hydrogens into the system. And again, you neutralize the negative O with this H2O H plus workup. So in this case, you cannot use sodium borohydride to reduce the carboxylic acid. You can only use lithium aluminum hydride to reduce the carboxylic acid. And again, you add two hydrogens in here. So you add two hydrogens in here, and it gives you a primary alcohol. Okay, so carboxylic acid with lithium aluminum hydride gives you a primary alcohol. The final one is the ester. Again, you can only use lithium aluminum hydride for this reaction. You cannot use sodium borohydride to reduce the ester. Excuse me. What happens in this, I've shown you guys the mechanism the mechanism for Grignard reactions with esters. Same thing happens with this one, but instead of R, you're using an H to reduce the compound. You add two H's into the system, to the carbonyl, the carbonyl. That's what gives you your primary alcohol here. This OR group gets kicked off, and it gets neutralized also by this H2O H+ workup. And this could be a primary, secondary, tertiary alcohol. It only depends on this R group and what it's attached to. So you form a primary alcohol always from this part. This aspect of the molecule always is the primary alcohol. Okay? And this aspect, or this aspect of the molecule, can be either a primary, secondary, or tertiary alcohol. All depends on this R group and what it's attached to. So there you have it. These are the main reactions and main types of problems you'll see, focusing on ketones, aldehydes, carboxylic acids, and esters. And let's do a quick little recap. Again, we're dealing with the reduction of carbonyls to form alcohols, and we're dealing with hydrogen and hydrogen sources. Similar to the Grignard reaction, instead of adding a R group into the carbon of the carbonyl, you're adding an H into the carbon of the carbonyl, and that's how you reduce the carbonyls, using H. The H serves as the nucleophile. Okay, the two sources of the hydrogen are sodium borohydride and lithium aluminum hydride. The four carbonyl compounds focused on are the ketone, aldehyde, carboxylic acid, and ester. You can use sodium borohydride to reduce only these two, and you can use lithium aluminum hydride to reduce these two. However, in this case, for these two compounds, you can only use lithium aluminum hydride to reduce the compounds. You can't use these reagents to reduce this. Okay, keep that in mind. That's really key. There might be some tricks that a professor might throw at you. So if you have a ketone using sodium borohydride, you get a secondary alcohol. So even if you use lithium aluminum hydride, you get a secondary alcohol. Again, aldehyde, you use sodium borohydride or lithium aluminum hydride, you'll get a primary alcohol. Okay, carboxylic acid with lithium aluminum hydride gives you the primary alcohol. And ester with lithium aluminum hydride gives you a primary alcohol based on this aspect of the molecule, and also it could give you either a primary, secondary, or tertiary alcohol. All depends on what this R group is attached to. If it's attached to three other carbons of the alkyl group, it could be a tertiary. It all depends on that. So there you have it. This is the reduction of carbonyls to form alcohols using hydrogen sources. And thank you guys for listening. I hope you guys enjoyed. And if you guys have any requests, please feel free to leave a comment. I'll be happy to make a video response to that request. Thank you guys, and I hope you guys have a wonderful day.